Hi kids. Well, here we are in week 4 and it's about math and the STEM, the M is math. And this is just can be great fun. And so today, obviously we have things in the world of measurement here before us. And you'll need to do a little bit of prep work to be able to do this experiment, but it's most fun. And you can do it over and over with different foods or different materials. It doesn't have to be food. I chose to use marshmallows today. And what I am trying to figure out is what is it like in the world of the accountant when he has to help the grocery store manager figure out what is the right size box to put his product in to fit the most product on the shelves to be able to sell to the customer to make the most profit to keep his business growing. And so here's a simple experiment to figure that out. First, you need some graph paper, and you want to have 3 pieces cut to the size of an average small box. Then you need 3 more boxes, tiny, a little bit bigger, and a little bit bigger, but all different shapes. Just look around the house. Any size will do. And then you want to figure out how much of a food you choose will fit in that shape when you line them up so you can count them and know how many are in each size box. And this will represent the shipping box that the grocery store manager will get his food in. He has to know, and he has to know the size of the shelves that his food is going on. So he has to measure them. You'll need a ruler and cutting the graph paper, some scissors would be good. And then you need your marker to be able to keep track of what you're measuring. So here's how this would work. I have pre-measured in the tiny box. I know that this goes like this. I know in the small box, I could fit 20 marshmallows in one layer. And so if I could fit 2 boxes of that size, I'd have 40 marshmallows. So pretend that's any other kind of food, like a can of beans, for instance. So each one of those marshmallows would represent a can of food or a piece of food that a customer could buy. Well, if the grocery manager used this size box, he would have 20 of that food, 20 marshmallows. And if we wanted to measure how many of those he could fit into the shipping box to get to his store, then we would simply put that in here and we'd mark off that with that small box, he could fit 1, 2, 3. That fits just right. Can we get another one in? Oh my goodness. It fits about right, and that was a sheer accident. So you could get 1, 2, 3, 4, 5, 6 of that box in there very easily. So if I had 6 of that small box in the shipping container, and there were 20 marshmallows, that would be 6 times 20 on each layer. And then let's just do the others real quick, and you can see how this adds up very fast. So the second size, we'll take that out. And we'll use the medium size. This one has 35 on one layer, and so we'd have 70 in a 2-layer box. Let's measure this one. How many could we fit in our box? Is it 2? Would that work? Goes right to here. Could easily get 2 in. There's even a little space left. But would we be able to get 2 more? No. It's too big to fit over to the other side. So even though this holds more, this holds 35 on one layer, you could only get 2 in the box. So that would be 2 times 35. And let's measure the last one. Now this box, longer and even flatter. What do you predict will happen with that? Math is all about predicting too, because that makes it even more fun to see if your prediction comes out right. If you eyeball this, does it look like you can get more than one in here? We don't know until we measure, but I do know that there's 72 marshmallows. So if we could fit 2 of these in our box, don't think we could get more than 2, but if we could fit 2 of these in our box, oh, that would be great. Let's see if it'll work. It doesn't. There's like 2 squares of graph paper less than we need to be able to fit 2. So even though that large box has 72 marshmallows, you can only fit 1 of them in the shipping container. So that would be 1 times 72. And I know you can add that up real quick, but let's do it together. 72. 1 times 72 equals 72. 2 times 35 equals 70. And 6 times 20 is 120. So, in this case, that grocer would be better off buying the small boxes of marshmallows because he could get 120 per row in that shipping box. He could have many rows in the same box, and he'd get more product in one box because it costs money to ship each box. And he'd be ahead of the game with that one. So each time you do this with each size box, it would come out a little different, and you can test different foods and predict each time. And that's the work of an accountant. And then he measures carefully and has to use his math, and that's how they find out how to help the grocery manager. So thanks, and I look forward to seeing you again real soon.